Okay, here we go. No one talk. If I'm taking the AP test, this is what I would do. What is the area enclosed by those curves? I have a calculator. First thing I do, graph both of those. So I grab my calculator and do that first. So, right there. Come on. Load you don't do. There, where? So I do that first. Question? Okay, the problem does not specify any, doesn't give any clues to the window. My advice, I have found 0 to 5 to be the best place to start if I don't know. Can't guarantee that's always best, but it's been pretty effective. So there we go. So I do 0 to 5, I do zoom fit, I end up with that picture. I'm like, got it. I'm supposed to find this area and this area. Now I might be a little worried that it maybe crosses again, so I just go a lot bigger just to make sure. So I'm going to go window. Like let's go, I don't know, -5 to maybe 15. I don't know, just to make sure here. Zoom fit. Yeah, that obviously 0 to 5 was a lot better because it's all happening right here. Like nothing's happening out here or out here. So back to 0 to 5 is good. Questions about anything? Please.
How do you know what area is the graph? Because it crosses the red line a couple times.
They want both because the question specifically says the area enclosed. Does that make sense? So this area is enclosed by both curves. This area is also enclosed by both curves.
So I wouldn't want the first kind of hole.
Right here?
Yeah.
Right, because it's not enclosed. Like this is not a barrier. This goes on forever. Like because the graphs separate.
Okay.
Can you see it?
Yeah.
Point. Okay. Drag this over just so we can keep it. Okay, this is a formula I have not shared with you because it hasn't been relevant. If I share it too early, you tend to overuse it. You don't want to use this formula only for kind of special cases. It's pretty easy to memorize, and it works great for calculator-based problems. Anytime you need to find the area between curves, like between two curves, just do this. Integrate the absolute value of one curve minus the other. Doesn't even matter the order. I only use this on the calculator portion of the test because I can't handle absolute value if I don't have a calculator. Make sure that after that minus you put a parenthesis because you've got two terms, x plus 5. Like that. Oops, that's last one's a bar. Okay, I need to find the limit still, but that will give me the area between the two curves.
Why do you do the absolute value?
The reason for the absolute value, so normally what we would do is we would create one integral, and we would take the top curve, subtract the bottom.
Yeah.
Then for this space, we'd have to switch it. Does that make sense? Because the curves switch. So we'd still be saying top subtract bottom, but the top will be different. You with me? The absolute value takes care of that. Because it says, I don't care which is top and which is bottom. I'm just going to find the difference and always call it positive.
So which Which area are we finding? Are we finding the first one or the second?
Both.
Both, okay.
So these are really good questions, Sydney Point. If I just need to find that area, I am not using absolute value. I'm just going to take the top curve, subtract the bottom curve.
Alright, can you do it, so you do like the integral of like the blue line, subtract the integral of the red line, and then do that again in the second?
And just switch it.
Yeah.
That's what you have to do if it's not on the calculator section. So the absolute value is just a shortcut on the calculator section.
Alright.
Good?
Yeah.
To the point. Please.
If it doesn't, if there's an absolute value and it doesn't matter which one's subtracting the other, then I also have x plus 5 minus the other.
Mhm.
Okay.
Yeah, that's what the absolute value does for you. And like I say, for a calculator problem, it works great because you just type in absolute value. When I'm doing it without a calculator, I can't have the bars. I don't know what to do.
Okay.
I can't handle those without a calculator. So, point. All that's left to do is find this x coordinate and find this x coordinate, and then you're done. That's it. Questions? Please.
Why don't you have to find the x coordinate in between those?
That's what the absolute value is going to take care of for you. Because it's going to take one curve minus the other. It's going to find these little rectangular heights. It just keeps going. And when they switch, it doesn't matter that they come out negative because the absolute value switches it back to positive. Without the calculator, I've got to do them separately. I'd have to find this intersection as well. Does that make sense?
Yeah.
Good point. Anybody else? Question? Please.
When you're solving an integral without a calculator, you have to anti-differentiate stuff in it.
Right, and so that's why, so if I don't have a calculator, I don't have any rule for how to find the antiderivative of the absolute value of something. So I can't do it that way. That's why I would have to do two separate integrals. Make sense?
Yeah.
Point. Because Talmadge is correct. If I'm doing it without my calculator, I've got to do the antiderivative first. Other questions? Okay, when I come to your desk, you tell me how many tally marks you earn.